This video is going to go through the sort of first part of our average rate of change example, where we practice finding some average rates of change and then also using those average rates of change to approximate the rate of change at a specific moment in time. And in this slide deck earlier, you saw sort of a definition for an average rate of change, but we've been dealing with rates of change all semester. When we go back to our very first module and we talked about covariation, we talked about how two quantities change together, and we looked generally at describing the rates of change. So in this particular situation, you were told that Emmett posted a video online, and this graph tracked his view counts as time went by. And so looking at this graph, there's sort of two clear pieces. And in fact, this is what we call a piecewise function. And maybe it's been a little while since you've seen one. We have both the graph and the equation of the function. And so with the equation, there's sort of two parts because there's two pieces to this relationship. Now, in the first section between day 0 and day 8, we notice that the view count is increasing, but it's increasing at a decreasing rate because each little increase is increasing by less and less and less. And so if we go and find sort of those rates of change between each of these points, we notice that the numbers would get smaller. And then in the second part of the graph, we're increasing, but at an increasing rate, and by larger and larger amounts. Now, in finding our average rates of change, we should see an agreement with this. So typically with average rates of change, the larger the interval, the less probably accurate that rate of change is for what's actually going on the function. So one way to sort of visualize or think about, so on this first problem, we're asked to find the average rate of change between day 0 and day 8. So basically, we're looking to find the change between the point 0, 0 and the point 8, 2 on this graph. And we can visualize that, and I'm going to use a yellow line, as sort of what we call in later math courses as a secant line. And so the secant line sort of shows what the line would be that has that average rate of change as a slope. And you'll notice that this line isn't anywhere really close to our graph, but it generally gets us from that first point to the second point. And so if we're just finding the slope here, or the average rate of change, sorry, it's the change in our output over our change in our input, and our output is 2 minus 0, and the input is 8 minus 0. And so that comes out as 2/8 or 0.25. And I like writing it in a decimal in this case because it's thousands of views per day. And so typically that's just, often more would be expressed as a decimal versus a fraction. And I might be going, okay, well, that's nice. I have sort of a general trend for that first section. But if I want to sort of have a better sense of idea, I'm going to shrink that interval down. So now, instead of going from 0 to 8, what if instead, oops, delete. I don't want anything clicked right now, but it's not letting me do that. What if instead we shrink this? And it's not letting me shrink this, but I'm going to try. Okay. And we're only going to go to 0.4. So we're going from 0 to 4. So now we've cut the interval in half, and you'll notice the line representing that average rate of change is a little closer to our function. It's not perfect. The closer, the smaller the interval, as I said, the probably closer we're going to get. Now, in this case, I still know that the point at 0, 0 is 0, 0 because it was given, but I don't have the point at 4, but I do have the equation. And remember, we're looking between, our inputs are between 0 and 8, so we're focused on this top equation. I don't even need to worry about that bottom equation yet. And so I can figure out the value at 4 by using my function. So if I input 4, the output would be 4 1/3. And I'm not even going to bother to calculate what that is. I'm just going to use the point, find the rate of change, and put it all in my calculator at once. And so in this case, my change in outputs is 4 1/3 minus 0 all over 4 minus 0, which comes out to be whatever 4 1/3 is divided by 4. Well, I should probably then put that in the calculator. And then we're going to divide that by 4, and we get 0.397-ish thousands of views per day. And yes, it is a little larger. Um, remember this is increasing at a decreasing rate, so the further along the function that we go, the smaller that rate of change is. And so in the first half, it does make sense that the rate of change is a little faster. But what if instead of focusing on the first half, we focused on the second half? And so what if we did between day 4 and day 8? Okay, so now we have 4 and 1/3 minus 2 all over 4 minus 8. Um, and so let's go update my calculator. I get 0.103. And again, makes sense because later on, as the input increases, my slope should be getting smaller. And so between here and here, my inputs have increased, my interval is increased, and my slope has gotten smaller. So this would be thousands of views per day. Now, if I'm sort of wanting to get, neither of these are getting me super, yes, they're better, but I'm still pretty far away from that, point, like what's happening exactly at 4. So what if instead I shrunk it even more? What if I went, instead of going, a 4, what if I just went, and now it really doesn't want to, what if we, can't even get it to work. Okay, we're going to just hand draw a line. What if we sort of were estimating those points there? Or if I even went on this side, notice my line between the points now is getting closer and closer. So what if we go between 4 and 6 and see if we get a, sort of closer rate of change? If I were, assuming, I would bet that the output here would be a little bigger than the output I got from 4 to 8, but maybe a little, but smaller than 3.397. Sorry, I'm having issues talking today. Okay, and then I plug that in and notice, yes, it's slightly bigger than the slope we had before, but smaller than the one between 0 and 4. Now, some people might be going, but you did the lower input value first. Does that matter? Keep in mind when finding an average rate of change, it doesn't matter what order I put these points in, as long as I'm consistent which point comes first. So if I am putting in the point with the input value at 6 first, then that needs to be, the same thing down below. Either way works. It's totally fine. I get the same slope, but the key setup here is that this is one of my points and this is the other point. So there's my output input. And as long as that's consistent, we're going to get the same slope no matter what. Now, yes, this is closer to what's happening at 4, but on the next question, we're asked to sort of get a really good estimate of exactly what's happening at 4. And for this, I'm actually going to switch completely over to Desmos for a moment because I want to show you something. When I'm looking at this, so what you see here is I've basically graphed the first piece of this piecewise function, and I've drawn in that line that represents our average rate of change. And you'll notice, okay, here's the line from 0 to 8, and we could shrink that down to 0 to 4, and you see, oh yeah, it was steeper. And when we went on the other half, it was less, not, it was less steep, because the rate of change was smaller. And as we shrunk that, we get closer, and you're like, ooh, that is pretty close. But if I went to the other side of my line, I wouldn't sort of be matching up quite yet. And so if I wanted to get a good estimate of what's happening, exactly at 4, and I'm going to switch this to 4, then I'm going to want to create an interval as small as possible, because the smaller the interval I create, the closer this line gets to being doing exactly what the function is doing. at this point, it's still a little separated, but if you could keep shrinking this down and down and down and down, and I make a super itty bitty 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 small interval, I'm going to be able to say, well, my line here is pretty much exactly the same as the graph. And so that's sort of so when I think about trying to estimate what's happening, I can say, okay, well, let's take that average rate of change, but instead of doing it over a really big interval, let's do it over a super, super small interval. And I might be able to sort of see what's happening it's not going to be exactly what's happening at that moment in time, but it's going to give me a pretty good estimate because it's a super small interval. So my personal favorite interval to do is I like to do 0.001. So like 1/1000th. It's tiny. And it's going to get me pretty darn close. And so what's happening here, let's go back to our slides, is we're going to then say, okay, if I want to estimate, I want to create an interval super close. So I'll have my point at 4, so 4 and 4 1/3. But then my next point I'm going to use is 4.001. So notice my interval here in the denominator, my sort of change in input, is super, super small. That's the key. I want a super, super small change in x interval. And so then I'd input 4.001 to the 1/3 and use those values to get my slope. And I'm going to, open back up my Desmos graph. But I'm going to switch back to a blank graph. And so what I'd put in, I have 4.001 and 1/3 minus 4 and 1/3. Sorry about my super sloppy handwriting. And 0.001 is our change in x. Oops, I forgot to do the 1/3. I was like, that number does not make sense. It helps if I put in the function correctly. Now, I technically picked a point above 4. So if I wanted to do a really good job, I would recommend also looking at a point below 4 just to make sure that, we take into mind, either side of the interval. Is it doing something different on one side versus the other? And we did say it's increasing at a decreasing rate. So I do know the interval above, even no matter it's super small, might be a little smaller than the value below. So my way of checking would be this time, what if I use the point, I'm still going to use the same 4 point, but what if we use 3.999? Still 1/1000th away. 3.9. Technically, this was a negative difference. And you'll notice that we end up with almost the same slope. Like for 3 decimal places it is. It's when you get further than that they start to get off. But that's telling me this is a pretty darn good estimate for the thousands of views per day that's happening. So I could estimate around day 4, he's getting about 132 more views per day for his video. And so keeping in mind, this is just sort of showing you in general, how do we find an average rate of change? But then one strategy we could use to estimate what's happening at a particular moment in time. And so we find that the smaller we make the interval, the closer that average rate of change is going to model the rate of change of the graph at a specific point in time. And keep that in mind as you sort of work through some of the practice this week.